Hey everyone, this is Mr. K, and we're here with video 14 of the Precalculus summer homework, the quadratic characteristics. So we need to find the vertex axis of symmetry, which direction it opens, x and y intercepts, and transformations for each without graphing. So, first, finding the vertex. This is written in vertex form, so what that means, like, this is a clue as to where the vertex lives. My advice, and this is typically how I teach it, is that whenever you have something inside parentheses, usually do opposite of what you'd expect. So in this case, the vertex is going to be at 4, -7. And then our axis of symmetry, if I'm envisioning this is like positive, so I know that it's going to open up. And that axis of symmetry is like the line that goes through and like cuts that parabola in half. So my axis of symmetry is going to be the line x equals 4. Hint, it's also kind of what makes that equal to 0. And we'll be using that later, something similar to that. And then after the axis of symmetry, let's go the direction that it opens. It's going to open up because it's positive. And then for the x and y intercepts, that's like the previous video we just did, where you substitute in a 0 for x, substitute in a 0 for y, and solve. So the first, if I substitute in a 0 for x, I would get -4. -4 squared is +16, and 16 minus 7 is 9. So I know that I'm going to have a y-intercept of 0, 9. And then I need to do the reverse. I need to substitute a 0 for y to find the x-intercepts. So if I substitute in a 0 for y, I'm going to get 0 equals x minus 4 squared minus 7. So I'm going to add 7 to both sides. Oops, forgot an equal sign. The next thing I'm going to do is I'm going to square root to get rid of that square. Don't forget the plus or minus. And then I'll have plus or minus the square root of 7, and then that's going to equal x minus 4. Last step is to add 4 to both sides, and now this is going to look a little funky, but our x-intercepts would be 4 plus or minus the square root of 7, comma 0. It's totally 100% okay to write it that way. I think that's a lot easier than going through and doing any sort of quadratic formula or getting decimals or anything like that. And the last thing we need to do is describe the transformations. So this 7 on the outside here, that's a vertical translation, or like a slide. And it's going to move it down 7. And then remember, like inside the parentheses, opposite what you'd expect. And so that 4 is going to be a horizontal translation. And that's going to move it to the right 4. And so that's all the information that they had asked for right there. The next one, same stuff. So vertex, notice how there is nothing with the x, so that x coordinate is going to be 0 for the vertex, and then +9. So our vertex is going to be at 0, 9. Our axis of symmetry is just going to be the line x equals 0, because that's what kind of makes this inside part 0, because there's nothing really there. And then it's going to, now because of this negative, it's going to open down. And then now for our intercepts, first if I make y equal to 0, I would need to solve for x. So let's start with x equals 0. So if I make x equal to 0, this whole thing is going to be 0, and we get 9. So not only is our vertex 9, or 0, 9, our y-intercept is also 0, 9. And then substituting a 0 for y, substituting 0 for y, we get 0 equals -2/5 x squared, and then +9. So first subtract 9 on both sides. and we'll get negative 9 equals negative 2/5 x squared. I'm then going to multiply by the reciprocal to get rid of this fraction, so I'm going to multiply by negative 5/2 on both sides. And then I'm going to get positive 45 halves, and that's going to equal x squared. And then square root both sides. Don't forget the plus or minus. And so we're just going to leave it like that. You can't really simplify it. Oh, I guess we should rationalize the denominator, so we'll do that part. So square root of 45 over the square root of 2, and then we can multiply the top and bottom by the square root of 2, and we get the square root of 90 over positive 2, and then this can simplify to 3 square root of 10 over 2. Don't forget the plus or minus. So our x-intercepts would be 3 square root of 10 over 2, and we want plus or minus that, and then comma 0. So it's a bit more intense for our x-intercepts. The last part would be the transformations. There's a few of them going on. The negative is like a reflection. Some say it's over the x-axis. Some technically it's over the line y equals 9. So we have reflection over the line y equals 9, or you could say the x-axis. We have a vertical compression of 2/5. And then the last thing we have is a vertical translation up 9. So sorry I got a little scrunch there, but that is all the information that we needed for that one. The last one is because it's set up like a quadratic formula type-ish problem, we can actually do this relatively quickly. So for our vertex, the x-coordinate is going to be equal to negative b over 2a. That's kind of like the first part of your quadratic formula. So if I do that here, remember this is a, this is b, this is c, so it'd be negative 6 divided by 2 times 2. So there'd be negative 6/4, which reduces to negative 3/2. And so the x-coordinate of my vertex is going to be negative 3/2 or negative 1.5. And then to figure out the y-coordinate, because again we're trying to do this without graphing, what we could do is we can substitute in that negative 1.5 in for x. And so what I'm going to do is I'm going to get my calculator out here, and I can just do 2 and then negative 1.5 squared. Type it in exactly like you see it. Plus 6 times negative 1.5, and then minus 8, and you should get negative 12.5. So that's going to be the y-coordinate of my vertex. The axis of symmetry is going to be the line y equals negative, or excuse me, x equals negative 1.5. This is positive, so it's going to open up. Our intercepts, first we can substitute in a 0 for x, and we're going to get negative 8. So I know 0, negative 8 is going to be my y-intercept. My x-intercepts, this would be set equal to 0, so we'd have 0 equals 2x squared plus 6x minus 8. You can solve this by either, you can solve it by factoring, solving by quadratic formula. It does not matter how you do it. I'm going to solve this by factoring, so if I take out a 2 out of everything, I get 0 equals 2 and then x squared plus 3x minus 4. I can just divide by 2 to get rid of that, and so I'm just left with x squared plus 3x minus 4 equals that. That factors to x plus 4, x minus 1. And so if I solve that, I should get x equals negative 4, x equals positive 1. So negative 4, 0, and then positive 1, 0 for my x-intercepts. And then the transformations. You can always just look to the vertex and kind of the a value for your transformation. So I knew that this moved to the left 1.5, down 12.5, and then because of this a value here, that's kind of like your vertical stretch or shrink or compression or dilation. So I have a vertical dilation of 2. We have a vertical translation down 12.5, and then we have the horizontal translation left 1.5, not 12. So that is all the information that they asked for that one. So again, I hope you found this video helpful and hope you have a great day.